In the second week, we will start Module 2. We will implement our first data structure class. So you can see here, we say that's a class. That's the first thing in this video. We will review some object-oriented program design concept. Data structure actually in C++ and Java, they both have an extensive library to support programming with data structure. In C++, that's in the standard template library. In Java, that's in the collection. For Python and PHP, they also support for data structure, but they have the built-in library. So data structure is something a programmer can use to store and retrieve data. So that's what we talked about from last week. Data structure example, we have many different examples like arrays, vector, maps, or a graph. So in this class, actually, we will create each data structure library. So each data structure actually is a class. From your prior courses in 165 or 200, sometimes when you implement one class, you have one header file including the class definition, and you have another CPP file for the member function implementation. But in this class, I just want to inform and emphasize, we will implement each data structure every week, but we're using one single header file. So on the other hand, that means in this single header file, you will have a class definition and all the member function implementation. That's all in one header file. So I will talk about Module 2 in few different lectures. So in this lecture, that's focused on object-oriented program design review. So we will talk about the class and the struct. And in C++, we have the this keyword and the double column binary scope resolution operator. So then we will talk about the member function. Sometimes they are getter function, sometimes they are setter function. So that's what we'll talk about in this clip. So the first thing talk about struct. From your prior courses, when we talk about object, we can define a class in a class or in a struct. So we have the C struct. So that came from language C. But also C++ including all the C language. So that's why the other way you can use to write a class. So that's C++ class. So sometimes students will confuse what's different between class and the struct. So honestly, they only have two things different. The first thing, the spelling is different. One is C struct, one is a class. Then in struct, by default, if you don't specify like this one, you have the student struct. If you didn't specify the how to be accessible, then by default, all the struct data are public. So here you will see here we have two member functions, output and input. So they are public access. So then if you want to have the private data, so you put the private at the front. So that's the only difference between struct. Different spelling. By default, they are public access. Then for class, we spell as a class. So then actually really no difference between struct and the class. The only thing is the spelling. And by default, class, the access is private. So that's why you see here the class student. I didn't specify how will be access for those data attribute. So then actually it's a private. So we have private data, name, student ID, and the float in the student. Then we have public member function. We have the output and input. So that's the difference between class and the struct. So either one, they can have the member function. So then you can implement afterward how the member function will do. So sometimes here in the member function, so here for example, we have a student struct. We have the member function called output. So we will display the name, ID, and GPA. So then here you will see after I declare this student struct. So in the same file, I want to implement the output member function. So then you will have, you see, not only you have the return type and the function name. Don't forget this function associate with your student struct. So that's why they need to have a double colon. We call that the binary resolution operator to make this function associate with this struct. So then you see we just set with and print name, student ID, and GPA. But sometimes you can do this way to direct to access the name, student ID, and GPA because we know they are referred to the host object. But sometimes if you have other name, they will, for example, we have the name. This name actually is from the student class. But if you want to define another variable also called name, we need to distinguish the local variable name with the data member from the host object. So in C++, we have this keyword. This keyword actually is a pointer. So this is a pointer referred to the host object. So we know pointer if you want to access or connect to the data attribute or member function. So pointer this, we need to use arrow. So then you can write this way. They are the same as earlier we show you. Name, student ID, and the GPA only. Or you can do the dereference. This itself is pointer. So then if you do the asterisk this, you dereference this pointer you refer as an object. So since this asterisk is an object, so that's why I use the dot. And also usually we put the parentheses because you see you need to have this dereference first become object, then you do the dot to invoke different data attribute. So that's this keyword and this keyword how we will use in C++. So that's one example about the member function. And also if you notice, actually this member function we have the constant keyword, right? Okay, so now the next one I want to talk about why we have this constant keyword. So we see the next example. So here actually is a struct, student struct define declaration. Then we have main function to run. So then here we have the student input and the student output member function implement. So you can see here output we have the const keyword, but input we don't have. So let's talk about the const keyword first. So whenever we are the member function, usually we call the member function, they are either setter function or getter function. So here, if they have a trailing const associated with the member function, this member function is a getter function. Why? Because this const, like last week we learned, const will protect the data won't be updated. So this const actually const what? They const the whole host object. So the const actually is associate all this, so the host object, those data attribute, they are private access and they cannot be modified, even you are the member function. So that's the const keyword actually is protect all the data attribute cannot be modified the value. So that's why here, right, you say, no, I write the output function, I didn't mean to change anything. Right, but because you didn't mean to change anything, if we don't put the const keyword, one day if accidentally someone else modify your function, they modify the name, student ID, then we cannot protect that. So that's why here in C++, we very protect our member function and host object. So if this function purpose is only for read the host object information, put the const keyword. So that's why we can protect. So that's why here, if we try to modify the name value, then they will give you the error. Okay, so that's the getter function. So instead, you see this input function, because the purpose is I want to update student name, student ID, and GPA. So that's why we didn't put const keyword. So this function purpose is we will update the data information, the host object information. So then you see we will have the name will update. So then your ID, you see we do the A to I, we read as a string. Then we convert the string to integer value. So then we can also update the GPA. Yeah, so this one actually is we say the setter function and the getter function. Actually, we need to be very careful. In C++, that's how we will protect our data in the class definition. So if you design this function as a getter function, put the const keyword. So then you see if this one you purpose is update the data, so then you will do the no constant keyword. So all the time when we do the getter function, we will have the const keyword at the end. So we protect the host object data. But sometimes even you do the getter function, right? So the getter function will use the get GPA, for example. Getter function, since you can update the data, so a lot of time you need to be careful. Whenever you try to update the data, we should always validate the data, because before you change to assign. So you see, setter function, this example is very good example we're using for this keyword. Because when I want to set a new GPA from the input, I still call that GPA. But this GPA is the parameter input. I want to update my host object GPA. So that's why they both call GPA, but I can distinguish with this keyword. So this one you update, right? But here you didn't validate data. If user accidentally give you the GPA is -5, they still update. So that's why a lot of time, whenever you try to write a setter function, we want you to validate the data before you can update the value. So then we can protect the data being updated is correct. So here, if you have any question about the video, make sure you post. Or if you are not clear, because sometimes I won't talk about line by line, word by word in the PowerPoint file, but you should read the whole thing, the example. So that's why all the time, please post and make sure you understand each slide, what I talk about. If you have question, write it down, so then we can go over during the Zoom meeting. So the last thing in this video, we will talk about inline function. So in this class, unless is only one line for your member function. Otherwise, after your class definition, you need to have the implementation afterward. For example, like here. Okay, you have your function struct declaration, but member function you need to define afterward. You need to associate with this class. One exception is what we call the inline function. The inline function only when you have, for example, your get GPA getter function, you only have one line. So this inline function is okay to put in your class definition. Otherwise, please have your function implementation outside the class definition. Then you have the function implementation afterward. And also here, don't forget either struct or class definition afterward you have a semicolon.